Hello everyone, welcome to Vishesh Educational Videos. In this video I am explaining about the APIs with respect to files. That means how you are going to interact with your files. If you want to open it, how you are going to do it. If you want to close it, how you are going to do it. So I am going to discuss about those APIs in this video. If you are not subscribed to my channel, please subscribe to my channel, and please don't forget to like the video, and please don't forget to share the video with your friends. To get the notification of my new videos, please click the bell icon. So let me begin the explanation. The general interfaces to the files on Unix and POSIX systems are, right, how you are going to identify the files, how you are going to open your files. First thing, files are identified by path names. Every file will have path names. In Unix you have a hierarchical structure, and that path names will be separated by slash, right? You know that. So for example, user slash vishesh slash csc, like that. So files are identified by path names. If you want to open the file, you can identify that by path names, and files should be created before they can be used. Obviously, if you want to use the file, first you should be created, then you can use it. Getting, guys? So files can be identified. How you can going to interact with your files means, first you have to create it, and then you can find out that file using the path names. For example, see, the various commands and system calls to create files are listed below. I told you, if you want to interact with your file, how you are going to do that? Using a command. If you want to open a file, for example, if you want to open a regular file, you can use a command, vi command. So it is going to open the file or create the regular file. This is the interface, application programming interface. Application programming interface means you can interact with your files. Your application can interact with your files. If you want to open it, you can open it. If you want to delete it, you can delete it. If you want to make changes to it, you can do it. How we are going to do it? Using these commands or system calls. Directory files. If you want to create the directory, you can use a mkdir command or mkdir system call. See, in this way you can interact with your files and directories. If you want to create a FIFO file, you can create with mkfifo. If you want to create a device file, you can do with it mknode. If you want to create a symbolic link file, you can create with ln-s. So if you want to interact with your files, you can interact with these APIs or system calls. Getting, guys? See, commands, what I am going to see. System calls are used by your OS. I am not going to see it. I will type it as vi, but OS will use open system call and it will open the file. I will use mkdir. Again, system call is also having the same name. It will use mkdir. Right? For example, to create a symbolic link, ln-s I will type. But what is the system call your OS will use? Symlink, like that. As a user, I will use only commands. System calls are taken care by your OS, APIs. APIs are nothing but system calls. So, for example, for any application to access files, first it should be opened, obviously, right? Generally, we use open system call to open a file. I already told you. And the returned value is an integer which is termed as file descriptors. So, you have to return the particular address of a file to your OS. That is file descriptor. File descriptor acts as a address of a particular file. And there are certain limits of a process to open the files. For example, a maximum number of OpenMax files can be opened. OpenMax gives the values of files that can be opened simultaneously. These values are defined in the limits.h header. Getting, guys? OpenMax means a maximum number of files that can be opened simultaneously. For example, the data transfer function on an opened file is carried out by read and write system call. See, I told you how we are going to interact with your file to modify it. You can use read or you can use write system call. Write means you are going to modify, means right, you are going to modify your file. So, and the same way, file hard links can be increased by link system call and decreased by unlinked system call. Hard link means for a same file you can create two or more paths. that is the hard link. You can create any number of paths for a same file that can be increased or decreased using this link or unlink system calls. File attributes can be changed by ch1, chmod. See what I am doing here. I can open a file, I can delete a file, I can make whatever the changes I want to my file. I can change the file attributes using ch1, chmod. I can change the owner information, user information using ch1, right? Like that. File attributes can be queried by using stat. If you want to check what are the file attributes of your particular file, you can use fstat system call. See, in this way I can interact with my file using these APIs or system calls. I can do whatever I want, right guys? So see, Unix and POSIX.1 defines a structure of data type stat. Here it is a structure, right? It is defined in cstat.h header file. This contains the user accessible attribute of a file. The definition of the structure can differ among information. That means structure means here I can group all the different types of data types in one place. In C programming data structure you have studied that, I think, right? So I can group different types of data in a same single place. I can do that. So here these are user accessible attributes of a file. User can access it and user can see this. For example, see, I created a structure by name stat. It is in the systat.h file. So first one is for file system ID, second one is for file inode number. I can access this, I can see this. See, second one is for file type and permission. Second and fourth one is for hard link count. UID will give the user ID, GID will give the file group ID. See guys. File size I can see, last access time I can see. All this information will be stored in this stat.h header file. That's why st is the prefix here. Hope you are understanding, guys. I can access all this information. I can see all this information of a particular file using system calls. Here I grouped all the different types of attributes in a same place using a structure. So hope you understood the concept, guys. Suppose if you have any doubts, please post your doubts in the comment section. Thank you for watching the video.